Hello and welcome to Calculus tutorial. We are continuing with volume. So we are still on the disk method, and we are going to now revolve around the y-axis. And so we're going to go around the y-axis and then any vertical axis in the coordinate plane. And so this is going to be very similar. So let's take a look at how do you revolve around the y-axis. So first, what does it look like when you're doing this, and how is that going to change our formula? So I took the same picture, turned it up vertically, so we can see what happens to our formula when our cylinders go this way instead of this way. All right, so our volume is still going to start out as pi r squared times height. But the radius and the height are now going to be different pieces of our function. So if I take a look at our circle, the radius of this circle is now going this way. And so just to show you one more time where the y-axis is, this is the y-axis. And then somewhere down here would be your x-axis probably. And so our radius is now the x value instead of the y value. And the height is now the change in y, not the change in x. And so that changes our formula quite a bit. Pi times the radius, which is x, times delta y is the same as dy. And so that is one way to look at your volume formula. Now, hopefully you can see there's a problem with that formula. The variables don't match. And so what you have to do is get rid of x. So usually you have a function y equals some function of x. And so what you have to do is, instead of having y by itself, you need to solve this equation for x, and over here you will then have a function of y. And then now that you know what x is, you can plug that in over here, so your volume becomes pi, and your radius is f at y squared dy. So you're doing everything in terms of y instead of x's because you are doing things vertically. All right, it is going to add one small step, but I think you'll see it's not too bad, and it really is the same process as before. Our main question stays the same. What is the radius? So we have a good idea of how that works. Let's actually revolve around the y-axis and see how the math works. So we are bound by the curve of f of x equals x squared. So we have a curve that comes up this way. And it says our other boundary is the y-axis, so this will be our other boundary here. And we're going from 0 to -1? Fair enough, we can do that. That's fine. Actually, let's change that to a +1. I think that'll make our lives a little bit easier. Okay, so we're going from there to there. And because we're going from 0 to 1, our y value up here will also be 1. All right, so that means this is our region here. And we are rotating that around the y-axis. So our question, as always, is what is the radius? So, because this is now my rotational axis, that is where the middle of the circle goes. Okay, yes, it does mirror on the other side, but we're not too worried about that. So what is the radius here? Well, that is simply the x value. So our radius is the same as x. And so our formula becomes pi r, which is x, squared dy, because we are going vertically. And we're going to start down here at 0 is where our cross sections start. And they go up all the way to y equals 1. Now again, we have the problem that the x's and the y's don't match. So we have to change this x into a y. And we go back to our function for that. So f of x is equal to x squared. Think of that this way. F of x is the same thing as y. So we have y is equal to x squared. Well, we need to get x by itself, so we square root both sides. And we get x is equal to the square root of y. Now I can take this and plug that in for x. And we have the integral from 0 to 1 of pi times the square root of y squared dy. Our variables now match. This integral can now be evaluated. And this is actually really easy because the square and the square root cancel out for us. And so we are just left with the integral from 0 to 1 of pi times y dy. Now, it must be said, when you plug that into the calculator, you are going to use x's, because you don't usually use y's on your calculator. So let's do that. The integral from 0 to 1 of pi times x dx. So the number will still be right. 1.571 is our answer there. All right, but remember, we are still doing pi r squared, and the big question is, what is that radius? That is where you need your own equation. All right, one more type of rotation then to look at. We did around the y-axis. Now we have to do a different vertical axis, because it doesn't just have to be the y-axis. Okay, so here we have an equation. And we have our axis of rotation over here, and that gives us this region. So we're going to rotate this region around the vertical line x equals 2. So when I draw the cross section, the middle of the cross section is right here. So it goes out, touches the boundary, and comes back. So our question is, what is the radius? What is that distance? Well, the distance from here to here is x. That is our x value. What is the distance from here to here? Well, that is always going to be 2. So you are going to add those two together, and your radius becomes x plus 2. Technically, if you want to do it in a mathematical way or in a more formulaic way, you always do big minus small. Well, this is the x value, so it will be x minus, what's the small number? -2. So you are still doing big minus small, and the two negatives make that x plus 2. Or you could just think of it intuitively as a distance and add those two together. So that's our radius. So the volume will equal the integral of pi r, which is x plus 2, squared dy. Because we are going around this way, we are stacking up our cross sections vertically. So we're going up and down this time. Now, where are we starting? Well, we're starting down here at y equals 0. These need to be y values. So yes, this is a x equals -2, but the y value is 0, and we're going up to a y value of 2. So everything is in terms of y, except this x, which we have to put in terms of y. So what is x in terms of y? Well, our function is y equals the square root of x minus 2, solve for x. Square both sides, so we have y squared is equal to x minus 2. Add 2 to both sides, and you're left with x is equal to y squared plus 2. Plug that in. So if we plug this in, can you see the 2 and the 2 we're going to add to be 4? So we're going to have y squared plus 4 squared dy. Now everything is in terms of y. I'm not going to plug that into the calculator for time's sake. You should have enough practice in doing that. Again, just make the y's x's when you plug it into the calculator. The number will be the same. The hardest part is getting to that formula there. All right, one more with this, because this is worth some practice. Vertical ones I think are sometimes the hardest to visualize. So we're going to rotate this around a different vertical axis. But our first question remains the same. What is the radius? Okay, so I think I forgot to highlight this region. So we're going to do this region right here. So that is our region. And we are going to rotate it around the line x equals 8. And so the radius is definitely going to be different this time. Here, let me get rid of that. It's a little distracting, isn't it? Alright, so it is going to rotate around here. If you want me to draw what it would look like on the mirror side, it would be something kind of like this, and our cross section would be something like that. Now, what is the radius? So you start in the middle and go out to the boundary there. Again, we don't really need the mirror image drawn to get the information we need, as long as remember that that circle, that cross section, the middle of it is on our axis of rotation. So what is that distance there? This gets a little tricky. Well, we don't know. What we do know is the distance from here all the way to here is always going to be 8. And we have a way to represent the distance from here to the function. That is our x value. So we want what's left over right here. So as always, we're going to do big minus small. So our radius will be 8 minus x. So our volume will be the integral. Let's see, vertically, where are we going? We're starting here at 0 still, and we're going all the way up to where? All right, we'll get back to that. Let's finish off everything else. Pi times 8 minus x squared dy. All right, we have to get rid of x. Okay, so if our function is y is equal to the square root of x minus 2, I think it's the same one as last time. Square both sides, add 2, so that x is equal to y squared plus 2. Now here's where you have to be careful. We're doing 8 minus all of that. So I'm going to use all the parentheses here, but hopefully you can see how the negative will need to distribute. Don't forget the pi. That's really easy to forget. So that will eventually become a negative y squared and a negative 2. So you could rewrite this as pi times 6 minus y squared if you wanted to. Or you could just, if you're typing it into the calculator, just put the extra set of parentheses. But we still need that upper limit. What is that upper limit? What is the y value right here? We're going from 0 all the way up to this y value. It's not super obvious what it is, so we simply have to plug in x equals 8 and see what the y value is. So if we plug in 8, 8 minus 2 is 6. The square root of 6 is not a nice number, so we'll just put the square root of 6 right there. And that is our volume. Again, I'll let you plug that into the calculator. Hopefully you're getting pretty good at that by now, and just switch the y's to x's when you input it. All right, that finishes up the disk method. All those are disk method problems. Next up is the washer method.